Okay, so we will start from the basics. We'll go with the flow. As soon as we complete this, we will take a look at the different applications and all the other important aspects. First, we'll classify the computer graphics. First thing is interactive, active or online graphics. So basically it is that type of graphics in which a person is involved. That is, for example, if you're playing games, you're involved with what is seen on the screen, or you're chatting with your friends. That is, basically the user is actually interacting with the graphics and then the changes are made in the graphics. Okay, so that is called interactive or active or online graphics. The second type of graphics or computer graphics is non-interactive or passive or offline graphics, where the person is not involved. For example, if you are going for a movie, whether you are looking at it or what you are thinking doesn't make a difference on the movie or the television. The movie is going on, you don't have to interact with it and you cannot interact with it. That is called offline graphics. Okay, now we'll take a look at applications of CG. Okay, CG is computer graphics. So from now onwards, whenever I'll see CG, it will mean computer graphics. So what are the obvious applications that come to your mind? First thing is entertainment. For example, games, what you play on your computer or your PS4 or anything. So there you need good graphics. Why you always say good graphics? Because when the visual effects are better, then you feel like it's almost surreal. Okay, these all the effects and all the graphics that you are talking about, that is basically computer graphics. So if you think you don't really like this subject, fact is the subject is actually interesting, but maybe your teachers or the books that you are reading for this subject may not be making this subject interesting. Trust me guys, as far as Indian education system is concerned, what I think is the books are from the 1990s that they are still referring. They are calling LED and LCD as the future technology. So imagine how old those books are. So that's why I'm saying, if those books are making you feel that this subject is bad, the subject is not actually bad. The way it is given to you is not correct. So I will try to make this subject as interesting as possible for you guys. So we'll take a look at the next application, simulators. For example, virtual reality. Okay, virtual reality as in those VR gas that you get right now. Okay, it has separate application in Android store called Google what do you call it, Google Box or something, or Google Cardboard. Actually it is Google Cardboard. So it is actually a simulator. Or example, even we can take a look at the simulators that they use in flight teaching schools for the pilots. Not all the pilots are taught at the start only on directly an actual aeroplane, because of course, come on, for a vehicle you can understand, but a aircraft is actually very much costly to be trained directly on it. So that's why they use simulators to get them practice first on the simulators. Or even the AutoCAD software, many of the mechanical people or civil engineers will know about AutoCAD. Third is 3D printing. Now 3D printing is a new technology. Okay, so these are some of the latest applications of computer graphics. What is 3D printing? You are actually getting the image in your computer, you are taking a look at it, how it will be actually designed in 3D on your screen, and then you are actually printing it with the help of plastic or that kind of material with a printer. So next application is presentation graphics. Okay, presentation graphics as in, you can think about this. Right now I am presenting you this topic. Okay, what am I using? I am using a PowerPoint presentation. Okay, what is it? It is at the end a graphics that is displayed on the screen. Okay, next is computer art. You all know about computer art. For example, our word art that can be used in our WordPad, or maybe even this thing, animations that you can see. There are some animations that are available for your screensavers and all. That is computer art. Okay, then comes CAD, computer aided design. That is also again used by mechanical engineers. Computer engineers also use CAD softwares nowadays. Then GUI. GUI is short form for graphical user interface. Graphical user interface is basically what you are interacting, how you are interacting with your computer or any device that can be called as computer. Basically computer is the father of all the electronic devices nowadays. Everything is a type of small computer. Okay, maybe it is your smartwatch, maybe it is your smartphone. It's at the end a computer only. Okay, next is education and ICT. ICT is information and communication tech. So basically nowadays we are using computer graphics even in education. For example, right now you're watching this video on YouTube. It is at the end a form of education that you're using it for. Information and communication technology. You can use Skype calls, you can use WhatsApp calls, you can send emojis. That is all the computer graphics that we are using. Okay. Next is virtual reality, which I have already mentioned on top. It is a kind of simulator only. And 10th one is image processing and computer vision. Image processing is basically, again, it can be a type of CAD only, computer aided design. You're processing the image. Okay, maybe your what do you call, Adobe Photoshop or Adobe video editors. Okay, so these are the applications of computer graphics. Now let's see what are the characteristics of graphics, computer graphics, that are actually expected. Okay, it has to be interactive. What is the use of a static thing on the screen? You will not enjoy something that is very much static on the screen. Okay, what you will do just by looking at it, it has to be interactive. For example, when you are playing game, it shouldn't be a game of screensavers that are just passing by and you cannot do anything about it. Okay, so it has to be interactive, so user gets more involved in the graphics and enjoys the graphics. It has to be user friendly. Okay, the graphics shouldn't be made only for the engineers who are making it. It should be so user friendly that anyone, maybe a 4-year-old or even a 60-year-old who doesn't have any idea about computers, maybe should be able to actually understand how simple it is or how it works. Okay, the dynamics. Okay, now there are two types of dynamics. Motion dynamics, that deals with how the object is going to move. For example, when you're playing games online, like let's say sniper game or maybe a cricket game, how the ball or the bullet from the gun is going to move from the gun to the target, or maybe from the bowler's hand to the cricket bat. Okay, and then next is update dynamics, deals with what changes the object is going to undergo. For example, you might have played Fruit Ninja. Okay, when you're swiping the fruits with your sword in the game Fruit Ninja, the fruit breaks into parts. So that is what happens, that the fruit goes under some change, it undergoes some change, and that is called update dynamics. So fruit was intact first, but when you swipe it with a sword, it breaks. So that is called update dynamics. And the fourth one is animations. So you all know animations, we have seen cartoons from our childhood, so I don't have to explain much about animations. Now we'll take a look at video display devices. Okay, first one, the most basic one that comes to our mind is cathode ray tube. Many of you guys are so young that you don't even know what are cathode ray tubes. I don't blame you guys for that. It might be there in your syllabus. Just because I said that these type of things are still taught, maybe just because you should know or you should get the gist from where it got started. So I don't totally disrespect what is the course that is being taught, but these are the things that were there before. Okay, so cathode ray tube, in olden days the TVs were huge. Okay, and they were made from this technology called cathode ray tube. Okay, so how a cathode ray tube used to work? So the operation is very simple of a cathode ray tube. What used to happen is there is an electron gun, okay, that emits a beam of electrons. Simple. Okay, they are called cathode rays. The electron beam passes through the focusing and deflection system, okay, that direct it towards the specified position of the phosphor coated screen. Now see, this is the phosphor coated screen and this is the electron gun. This part is called electron gun. Okay, so it shoots a beam of cathode rays. Okay, or you can see over here, this is how it is passing. Okay, now we have something called focusing system over here. When the beam hits the screen, the phosphor emits a small spot of light at each position contacted by the electron beam. Okay, now what does this focusing system do? It helps in positioning the beam, electron beams, on the screen. And this Y deflect and X deflect, basically those are deflection plates. Okay, so deflection plates are basically, they also help in positioning, but also maybe like Y deflection means where to position it on the screen on the Y axis, where to position the cathode rays on the X axis. So basically these deflection plates provide that. Okay, and what is this control grid voltage? So control grid voltage supplied actually controls the brightness of the visuals. Okay, so some of the spots may be dark, some of the spots may be bright. This is used for creating black and white pictures. Okay, This was the oldest technology, so they used to use it only for keeping either it should be dark or it should be full bright. So this is the thing which was first developed. Okay, it redraws the picture by directing the electron beam back over the same screen points quickly. Okay, so it again and again displays the same thing by again and again positioning those cathode rays at that position, okay, by re-emitting it. This is the structure. You can take a look at this. This is the bees, these are the connector pins, this is the electron gun from where the cathode rays are passed. Focusing system focuses it at one point. Y deflection plates and X deflection plate, that is, these are the directions in which they deflect the rays. Okay, and then this is the phosphor coated screen. When the rays hit the screen, what happens is that spot is illuminated, and that's how the pictures are found, by illuminating different spots and trying to make a picture out of it. Okay, what is a pixel? Okay, smallest addressable screen element is known as pixel or pel. Okay, now what is resolution? You might have heard this term a lot. Maybe this might even come as a question in your exam. Define resolution. So what is resolution? The max number of points that can be displayed without overlap is referred to as resolution. What does that mean? Now, in a simpler definition, the number of plot points, okay, per centimeter that can be plotted horizontally and vertically. You might have seen these resolutions provided on your laptop screens or your television. They say 1024 by 640, okay, something like that, or maybe 1860 by 1260, something like that. So what it is basically the number of points per centimeter, okay, and it is horizontal by vertical. So how many points are there horizontally and how many points are there vertically? As you can see, the screen is actually wider and not that longer as compared to the width. The width is always more than the length. Okay, so that is how it is, horizontal versus vertical. Now there are two types of resolution. First one is image resolution. It is also called spacing. So what is image resolution? Distance from one pixel to next pixel is called image resolution. Okay, and second one is screen resolution, the number of pixels in the horizontal and vertical direction. Okay, yeah. Now some of the other important terms that can be asked in your exams are as follows. First one is aspect ratio. This might be something that you might know already, because you might have used video players or your mobile screens. You might have seen some videos, okay, or even YouTube. So what does it show? It shows some aspect ratio, okay, the ratio of vertical points to the horizontal points necessary to produce equal length lines in both direction of the screen. Basically, how many number of points are there vertically and is to how many number of points are there horizontally, and then we take a ratio of it. For example, 16:9, you must have seen this ratio, or 4:3. If you have not seen this, just open your video player, window media player or VLC player, you can check, and then you can just click A button. It will show you different aspect ratios, 4:3, 16:9, 2:23:1, something like that. Okay, so basically that is aspect ratio. It is number of points on the vertical is to horizontal points. Okay, so basically it is a ratio of vertical and horizontal points. The next important term is frame buffer. The memory wherein the picture definition is stored is known as frame buffer. Okay, so, or refresh buffer also. It is also called refresh buffer. This memory area holds the set of intensity values for the screen points. So just like I had told you, now we illuminate different points on the screen to display an image. Okay, so it's not actually an image. We are just trying to display as close as possible to that image by illuminating some points and not illuminating some other points. Okay, so what it is, these are the picture definitions that are called, which are stored in the memory buffer or frame buffer. Okay, and from there we get to know which points on the screen have to be illuminated and which we don't need to illuminate. Okay, so all those data is stored in the frame buffer. Okay, now what are the types of displays? Now types of displays, CRT monitor, I doubt you will see now in today's world. Okay, but we'll still learn about it. First thing is a CRT monitor display. It displays color picture by using combination of phosphor that emits different color light. Okay, so just like our cathode ray tube, okay, which used to just illuminate the screen. Over here what has happened is in CRT display, now afterwards the technology was advanced. So what it used to do is it used to have different colors of phosphor that were coated on the screen. Okay, so it used to use a combination of those two things. By combining the emitted light from the different phosphors, a range of colors can be generated. The two basic techniques for producing the color display with CRT are beam penetration method and shadow mask method. Okay, so first we'll take a look at two types of CRT monitor displays. Okay, now first type is beam penetration display. So what is beam penetration display? Beam penetration display is as simple as it sounds. Basically, the beam penetration method for displaying color pictures has been used with random scan monitors. Okay, two layers of phosphor are usually red and green are coated onto the inside of the CRT screen. Okay, and the displayed color depends on how far the electron beam penetrates into the phosphor layer. Okay, a beam of slow electron excites only the outer red layer. Okay, the beam of very fast electron penetrates through the red layer and excites the inner green layer. At the intermediate beam speed, combination of red and green lights are emitted to show two additional colors, orange and yellow. The speed of the electron and hence the screen color at any point is controlled by the beam acceleration voltage. Now I'll explain you guys what does this mean with the help of this diagram over here. Okay, so suppose this is our electron gun. It is passing cathode rays, and over here on the screen, the whole screen is covered with the outer red layer color, and that is phosphor of that color, and another is green color. So what used to happen is, suppose if the ray is too slow, what it will do, it will only excite the red layer, so it will show red display. If the beam is too fast, what it will do, it will penetrate through and it will display green color. Okay, suppose if the electron beam is of slow speed or intermediate speed, okay, what it will do, it will provide a little bit of red and green combined, so it will give us yellow color. Okay, and if we change the speed little bit more, but in the intermediate range only, then what will happen, it will display yellow color. Yellow and orange are the two colors which are generated by intermediate beam speeds. Okay, so this is how it works with the beam penetration display. Now next one that we'll take a look at is shadow mask display. So shadow mask method are commonly used in raster scan displays, including color TV, because they produce a much wider range of colors than the beam penetration method. Okay, so this was used for the long time until the LCD and LED TVs came. Okay, so these were the types of displays that were used in say let's say early 2000s onwards, so that you could get a color picture on the CRT TV. Okay, but with a much better range of colors. So a shadow mask CRT has 3 phosphor color dots at each pixel level. Imagine, in other case, in the previous case, in the beam penetration, the whole screen was covered with only 2 layers of phosphorus of green and red color. But over here in the shadow mask display, what we use is, we use 3 types of different colors at each pixel position. So it was very, what you say, like complex, because every pixel has 3 different color dots of phosphor. Okay, one phosphor dot emits a red light, another emits a green light, and the third emits a blue light. Okay, now this type of CRT has 3 electron guns, one for each color dot. Okay, and a shadow mask grid is just behind the phosphor coated screen. So this is how it looks. Okay, so what happens, this is the electron gun for blue color, this is for the green color, this is for the red color, and this is the shadow mask. Okay, so what it does is, with the help of this shadow mask, it positions all the 3 beams on each pixel such that it produces a combination of all these 3 colors at each separate pixel position, giving us a look of different colors. Okay, what are the color combinations that will take that if you want, you can check my another video where I have explained some of the important questions for examination, in which I have explained how to get the different colors. If no, I will provide you guys with a file which explains that also. I will make a separate PowerPoint presentation for that and provide you guys with the different color combinations of a CRT with these 3 colors. Okay, and this is the phosphorus screen. So this shadow mask is used basically to position all the 3 beams on the phosphorus screen. Okay, Now the third type of display is direct view storage tube. Okay, so what does this name suggest to you guys? Direct view storage tube. An alternative method for maintaining a screen image is to store the picture information inside the CRT instead of refreshing the screen. Okay, so a direct view storage tube stores the picture information as a charge distribution just behind the phosphor coated screen. Two electron guns are used in DVST. One is the primary gun that is used to store the picture pattern, and second one is flood gun, maintains the picture display. So basically it is somewhat like this only, but what happens is the whole picture definition is stored. Okay, it is directly stored behind the screen, and one is used to store the definition, one electron gun, and one electron gun is used to keep continuously passing the data, passing the electron rays, so that we can maintain the picture on the screen. Okay, now but there are some advantages and disadvantages of DVST. DVST is direct view storage tube. What are the advantages is, because no refreshing is needed, very complex pictures can be displayed at very high resolution without flicker. So basically you can store as complex picture as you want, because there is no refreshing. We are just storing the picture directly. Okay, we are not refreshing it, we are just passing the data again and again. Okay, and disadvantages is they ordinarily do not display color. Okay, color definitions are difficult for this, and the selected part of the picture cannot be erased. Either you have to eliminate the whole picture or you have to keep the same picture. To eliminate the picture section, the entire screen must be erased and the modified picture is redrawn. So this might take several seconds. So this is the disadvantage. You cannot make changes or you cannot make animation, maybe a walking person on the screen, because that is a part of the screen that is changing. We cannot do that changes in DVST. It is only good for complex and static pictures. Okay, now the next one, flat panel displays. This you guys must be aware of, because you can see your mobile phones, your television nowadays, or your laptop screens. These are all flat panel displays. The term flat panel display refers to a class of video devices that have reduced volume, weight and power requirements compared to a CRT. As you can see, your TVs are like hanging on the screen. You have display in your hand. It is so light. Okay, a significant feature of flat panel display is that they are thinner than CRTs, of course, and we can hang them on walls or wear them on your wrist. Smartwatches, guys. And types of flat panel displays. Okay, first one is emissive display. Okay, displays that convert electrical energy into light. Okay, plasma panels, thin film electroluminescent display, and light emitting diodes, or you call it LEDs nowadays, are the examples of emissive display. So what basically this emissive display do, they take the electronic energy or the current, they convert it into light, and then they use that light itself for display purpose. What are non-emissive displays? Non-emissive displays are non-emitters. Okay, they use optical effects to convert sunlight or light from other sources, okay, into graphic patterns. For example, your LCD doesn't have its own light source. It uses a separate light source for display purposes. Okay, I don't know, you guys must have seen these watches. Used to get some digital watches in the olden days. Maybe it was there during the early 2000s only, where you had an external light that you had to turn on so that you could see the time in your watch. Okay, and I don't know whether you get those watches nowadays or not, but these were the types of display, and they were made from LCD, so they were non-emissive display. Okay, the most important example of a non-emissive flat panel display is liquid crystal device, also called LCD. Okay, so this is how a LCD look, guys. Okay, it doesn't have its own light source. You have to provide an external light source for it. Okay, and this is how an LED looks. You can see this is made of light emitting diodes. Okay, there are thousands of light emitting diodes over here, and they are illuminating, that is, they are converting the electrical energy that is provided to them into a light energy. Okay, thank you guys for watching. Please like the video if you really understood and enjoyed this video. Please share this video with your friends who are also struggling in this subject. I'll try to make as many videos as possible as soon as possible for you guys. Please subscribe to the channel if you haven't, and please like other videos also. Do ask me any questions if you have in the comment section below. Thank you guys for watching. See you in the next one.